Kinetic particle theory. States of matter. The matter is a substance that has mass and fills in space. Matter can be present as solids, liquids, and gas, which are known as states of matter. These states can be changed into one another by changing the temperature or pressure. Properties of solids, liquids, and gases. Solids have fixed shapes and volumes and are incompressible. Liquids and gas do not have a fixed shape. Liquids take the volume of the container and are incompressible. Gases do not have a fixed shape but can be compressed. All of the matter is made up of small particles that continuously move around in random directions. This theory is known as the kinetic particle theory. The moving particles have kinetic energy, which is why it is known as kinetic particle theory. This theory describes the state of matter and explains its changes. Also, it differentiates between the properties of different states of matter. Solids are packed in an organized manner and are close to each other. Particles of a solid have powerful forces between them, they cannot move around randomly and only have little kinetic energy to vibrate about their fixed positions. This is why solids are in a fixed shape. The forces of attraction between the solid particles are sturdy, which is why it cannot be compressed quickly, hence having a fixed volume. However, in a liquid, the particles are not in fixed positions and can move in a disorderly manner. They have weaker forces of attraction between their particles, hence they do not have a fixed shape. Their kinetic energy is more than solids. Particles in a liquid are distant than solid, that is why they cannot be compressed and have a fixed volume. Gas particles are furthest apart, which is why they have the weakest force of attraction between them. The kinetic particle theory explains that they have much kinetic energy and can move about freely in an unorganized manner, hence they do not have a fixed shape. Gas particles are furthest apart, hence they can be easily compressed, which explains gas has no fixed volume. Changes of state and kinetic particle theory. Temperature and pressure of the surrounding can change the physical state of a substance, for example, ice changing into water and water changing into water vapors. Changes of state can be reversed, for example, water can be changed into water vapor, and water vapor can be changed into liquid water on cooling. Melting, boiling, freezing, and condensing are examples of changing of state. Because all particles of matter are always moving, hence they possess kinetic energy. Gases have the highest kinetic energy, while solids have the least kinetic energy. The substance changes its state when the temperature of the surrounding is increased or decreased. When solid changes into liquids, is shown in graph, it absorbs heat energy as the temperature rises. When the temperature reaches the melting point, solid is said to melt, and the process is known as melting. The temperature remains constant while the particles absorb the heat energy. Thus both solid and liquid exists. When the temperature rises, the heat energy increases, and liquid converts again into gas. The change of liquid to gas is known as boiling/vaporization, which only occurs at the boiling point. The graph below is known as a heating curve as it shows the changes of state while the temperature is increasing, and the reverse of it is known as a cooling curve when the temperature is decreased and the particles lose their heat energy to convert from solid to gas. Evaporation is the process of liquid changing into gas, but occurs below the boiling point. Boiling and evaporation are different. Boiling occurs only at boiling point throughout the liquid, and it occurs rapidly, whereas evaporation occurs only at the surface and below the boiling point. When the temperature decreases, liquid changes into solids, and when liquid freezes, the temperature is known as freezing point. When a gas changes into a liquid, it is known as condensation. Gas loses its heat energy, the gas particles slow down and move closer to one another. When solid changes into a gas without melting, it is known as sublimation. Solid carbon dioxide, iodine and ammonium chloride are some examples of the solids that sublime. This process is used for preservation, refrigeration, and transport of frozen food items. Heat energy is absorbed during melting and is lost while freezing. Those liquids which quickly evaporate at room temperature are volatile liquids, their boiling points are just above room temperature, for example, petrol and perfume. Diffusion and everyday effects of diffusion. Gas particles have the highest kinetic energy and can move around freely and in all directions, which is why we can smell gases when they reach our nose. The gas particles taking up the space of a container or closed area is known as diffusion. For example, we can smell perfume in coffee/tea or an aroma of food cooking at your home. Diffusion not only occurs in gases but also occurs in liquids. For example, copper sulfate crystals turn the color of water blue in a beaker and form a homogeneous solution. Homogeneous means that the particles are evenly spread throughout the container. The motion of particles from higher concentration to lower concentration is known as diffusion. Factors that affect the rate of diffusion. 1. Temperature. 2. Molecular mass. Temperature. Increased temperature causes the particles to absorb heat energy, which converts into kinetic energy, and hence, particles move faster. This explains that the rate of diffusion is more significant when the temperature is higher and vice versa. Molecular mass. The rate of diffusion is higher if the molecular mass is smaller, and it is slower when the molecular mass is higher. This explains that the gases do not diffuse at the same rate. The molecular mass of ammonia is lesser than hydrogen chloride gas, which is why it diffuses faster than hydrogen chloride. Molecular mass of ammonia equals 17 grams per mole. Molecular mass of hydrogen chloride equals 36.46 grams per mole. The effects of temperature on the rate of diffusion. Rate of diffusion is higher whenever the liquids are heated or the temperature of solution increases. For example, salt dissolves quickly in hot water. The particles gain kinetic energy when they are heated, which is why they can move around quickly, hence increasing the rate of diffusion. This means that gases diffuse rapidly than the liquids because gas particles have relatively higher kinetic energy than liquid particles.